So I'm here to discuss artificial neural network. So as the name suggests, artificial neural network are just like our biological neural network. That is, in the biological neural network, we have neurons, and here we have nodes. It processes the data based on examples. It does not have any prior knowledge of any object. It learns the data, it learns the object through training on based on some examples. And this type of training is known as supervised training. So in supervised training, the data set is divided into training data and test data. And in training data, we train our artificial neural network and then it gets tested on the test data. So the ANN does not have any prior knowledge of things. It gets to know things through examples. Same way our brain works. We get to identify the objects based on our day-to-day activities. So here is the architecture of our neural network. It is the input layer. The input layer, it gets the data from external sources and it then forwards it to the next layer. These are hidden layers. In an architecture, there can be one or more hidden layers. The more the hidden layer, the more complex the system gets, but the more efficient the system gets. Here, this is one node. These are nodes which processes the data and then forwards it to the next layer. The hidden layer one, it gets forwarded to the next layer. Same things happen here. It evaluates the data. It evaluates the data from the input it gets from the previous layers, and then it forwards it to the next layer. Here is the output layer, which gives us the output of the whole network. So what are the components of the artificial neural network? First is neuron. Neuron is nothing but the node which receives the data from the input layer, or which receives the data from the process from the previous layer. Here, like this is a new node. This is a node. It gets the input from the previous layer. So here, the input will be the output of this node. Connection and weights. The connection is nothing but these are the connections. Each node is connected to the node of next layer, and if every node is connected to the to every node of the next layer, and every node of the next layer is connected to every node of the previous layer, then we get a fully connected network. Like here is an example of fully connected network. Every node is connected to every node, as you can see. So these are the connections, and with each connections, weight is associated, which gives its relative importance. So a neuron can have multiple input and output connections. So the propagation function. So the node is divided into two parts, the summation function or the propagation function and the activation function. So what propagation function does is it computes the weighted summations, and then a bias term is added to it. This is the main work of propagation function, and the result is then forwards to the activation function, which can be anything, a sigmoid, a tanh function. A weighted sum is calculated and a bias sum is added at the end of the result. And this function is associated with every node. Every node in the hidden layer, every node from the hidden layers onward, not the input layer. It has two parts, that is the propagation function and the activation function. The propagation function evaluates the inputs and gives the weighted sum and the bias, and then it gets forwarded to the next to the activation function. So the whole organization, the whole network is divided into multiple layers, and the input layer, the hidden layers, and the output layer. So what input layer does is it gets the data from the external sources. The main function of the hidden layer is to process the data, to evaluate the inputs, and the output layer is there to give us the result. So hyperparameter. Now hyperparameter is a value that we get by training. It's a hyperparameter is a parameter that defines that eventually evaluates the value of every parameter, be it W or V. So this is very important. An example of hyperparameter is the learning rate. And hyperparameter is it's derived via training. You cannot set a value beforehand. You cannot get a value, and that can be true for every network. Each network has a different value, and the value gets modified as the system enhances itself. So the learning is how the system gets acquainted to its acquainted to the outputs, to the inputs, and it how it enhances the result and the accuracy of the result. So the main purpose of the learning is how to get better of that network. it it adjusts the value of weights and the hyperparameters to get the accuracy of the result. And as long as the output continues to decline, the learning continues. We will get to this line later. So first we'll know what's cost function. The cost function is the measure of how accurate our network is, how close it is to the real life. So it measures the accuracy of the network, and it is advised to have minimum cost function. Minimum cost function is always required, and cost function, before calculating the cost function, we always calculate the loss function. Loss function is always calculated on a single training set, and then we get to know the cost function. So backward propagation is nothing else but traversing the network backwards. So backward propagation helps us to adjust the value of W so that we can get minimum loss. And here, as you can see, the backward one of the ways to calculate backward propagation is through gradient descent algorithm or by computer derivatives. So as here you can see, there is a starting point. So after one backward propagation, the cost function comes to this. After third iteration, it comes to this. After fourth is this, and eventually it comes to this point. This point is the minimum point. This point is the point where the cost function is minimum, and each network's uh, each network wants to get to this point. This is the point where every network wants to be, and it is through backward propagation that we get to this network, to this point. So the working of the artificial neural network. So as we discussed earlier, this is the input layer, and these are there is just one hidden layer, and then there is an output layer. So the input layer will get us the data, and then it forwards it to the hidden layer. See, the hidden layer is divided into two parts: the weight and the bias part, where we get the weighted sum, and the bias is added to it. And then there is the function, activation function. Now, activation function, as discussed earlier, can be anything: a sigmoid function or tangent function, depends what network we are working on. And similarly here, and then it forwards it to the next layer, which is the output layer here. Now this is the forward propagation. For the backward propagation, here I have drawn a diagram. For the backward propagation, like here, the blue arrow represents the forward propagation, and the yellow arrow represents the backward propagation. So J is equals to 3V. For backward propagation, we will we will have to derive the derivative of J with respect to V. Similarly, we have to get to the derivative of V with respect to A, U with respect to B and C, so that we can get the backward propagation and then adjust the value of weight and bias, so that right weight quantity is chosen to get minimum cost function. This is the main purpose of backward propagation, to get minimum cost function. Some of the advantages of artificial neural network: it learns itself. One of the main importance of it, one of the main advantage of it is it learns itself and it enhances itself. You don't need to work on it; it works on itself. Then it generalizes itself. Then it do not impose any restrictions on input variable. Now, application of artificial neural network is image processing to see whether it's a cat picture or not. It's just an example. Character recognition, forecasting, where you already have data from previous years. And it's generally used in cases when the past is repeated almost exactly, because much variation in data in the data set will lead to an output which we don't want. So this is it from the artificial neural network. Thank you.